Okay, getting most of the stuff I've got over here, that's down the road a ways. Okay. Good ways. Okay. System equations, okay? I can rewrite the system like this, understanding that the coefficients of X go here, coefficients of Y go here, and whatever's to the right of the equal sign goes here. Okay, so we see that this can represent this system. Then we don't have to write all the X's and Y's. That's one advantage. There's much more to it. That'll do for right now. Okay. I could do half of the first row of this matrix, which would give me 1, 7 halves, 11 halves. And then I can write down the second row just as it is. Okay, can you write down what equation this would be? With the X's and Y, just the first row, what equation would that correspond to? When I got the one there, you're writing down that whole.
Yeah.
You're writing down the first row of the previous matrix.
Yeah.
So you're not gonna get a 0 there, because the first row didn't have a 0. First row is 1, 7 halves, 11 halves.
1 times 4. And average 2.
Well, you're not gonna multiply anything. Well, yeah, you can multiply that out over here. But you're not changing the first row, you're changing this row.
Change this one.
Okay, let me write it out for you. I see where you got the 0. And that's right. That's the next thing I wanted to say.
Yeah, I should put it on the second row, and the first row is the 1, 7 halves.
Okay. We write down the first row, there it is. We're not changing the first rows. So let's clarify this. Okay, a little bit of confusion. Didn't have a recorder, I'm just gonna say what I just said. Write down the first row, we're not changing the first row, that's what the 1 means. Take the first row of this matrix here, and just write it down. Then we got to do 4 times the first row and add that to the second, okay? So let's first, what's 4 times the first row? And write that out someplace way off to the side, so it doesn't influence the matrix, okay? I swear that Zoom just doesn't want to. Okay, if I do 4 times the first row, I've got to multiply 4 by everything in the first row, okay? So we're talking about 4 times the first row as it was before. So we look back to this row, multiply by 4 here, we get 4. We multiply by 7 halves, we get 14. We multiply by 11 halves, and we're gonna get 22. Okay. So here's 4 times the first row plus, okay, this is. Well, okay. So here's 4 times the first row. That's here. And the second row is -4, 3, -5. Here's the second row. And then we add. So what do you get when you add? Well, you're not gonna have any trouble adding them. You're gonna get 0, 17, 17. And that's what you're gonna write down here. Badly written. So let's improve it a little bit. So we read it. Okay, now I'm going to bring that same matrix up here just so we can always look up. See, we got 1, 7 halves, 11 halves, 0, 17, 17. Now that's exactly what we would get if we took half of this first equation. And then multiplied it by 4 and added it to this. So we're still equivalent to our original system. Next, we want to divide this one by 17. Okay. So we're going to want to write down the first row, which is okay for now, and the second row divided by 17. So what matrix would you write down? If you did that. Okay, so what do we do here? We write down row 1. And in row 2, we divide everything by 17. 0 divided by 17 is 0. 17 divided by 17 is 1. 17 divided by 17 is 1. Okay. Then we're going to take row 1. And subtract 7 halves of row 2. Now, we're not going to change row 2. We've got row 2 where we want it. And what I mean by that is, okay, let's back up for a second. What equation does that stand for? Okay. How would you write out the equation that corresponds to this row? Can you write that out off to the side someplace? Okay, now let's think about why we might have done this. This row corresponds to 0x plus 1y equals 1. Now, I have been writing down my dotted lines here. So what this means. This stands for y equals 1. We've got a solution for y. We know that y is going to equal 1. That's going to find, we're going to find that x equals 2, but let's do the matrix and see how it comes out. Okay. So what do we get if we subtract 7 halves of row 2 from row 1? don't multiply this row by 7/2 in the matrix. We're gonna leave this as it is because this already tells us what our solution is for y. We don't want to mess with that. In other words, our row 2 is gonna stay the way it is. A lot of people want to multiply this row by 7/2. This doesn't say multiply the second row by 7/2. It says take row 1 and subtract 7/2 of row 2. Okay. Now you might want to write out the details off to the side, kind of the way I did here. Let's see what you get if you subtract 7/2 of row 2 from row 1. Okay, thanks for pointing out that the camera wasn't, yeah, camera wasn't recording. Okay, so again, there's a reason we're doing this, but we're going to see what the reason is just by doing it, and then we'll work through one ourselves. Okay. So we're going to do row 1 minus 7/2 of row 2. Now I don't have a good place to do this. I want to do it way away from these matrices. Okay. But I'm going to squeeze it in right here. So. Okay, I'm going to write down row 1, which is 1, 7/2, 11/2. And then I'm going to write down negative 7/2 of row 2. That might be hard to read because I'm trying to squeeze things in. Not doing a good job of it. But what's negative 7/2 of row 2? Well, row 2 was 0, 1, 1, right? Negative 7/2 of 0 is 0. Negative 7/2 of 1 is negative 7/2. Negative 7/2 of 1 is again negative 7/2. When I add these up, 1 and 0 gives me 1. 7/2 and negative 7/2 gives me 0. 11/2 minus 7/2 is 4/2. And 4/2 is 2. So what I get when I do this calculation is 1, 0, 2. Well, I'm done. I've solved the problem. Because what equation does this correspond to? And what equation does this correspond to? Well, you've already written it out, that the second equation corresponds to y equals 2. What's the first equation correspond to? It'd be x plus 0y equals 2. That's our y equals 1. And this is then x plus 0y equals 2. Let's write it out more explicitly. Okay, we don't have to write the 0x and the 0y. We see that our solution is x equals 2, y equals 1. Now let's check that back in our original equations. If you plug in x equals 2 and y equals 1, you get 2 times 2, which is 4, and 7 times 1, which is 7. 4 and 7 equals 11. It works. Okay, what do you get for the second equation? We'll write out the second equation. We'll have the arithmetic and verify the second equation for us. Okay, x equals 2, y equals 1. We're going to bring that back up here and plug it into the equation. So we're going to swing around here, up here, plug it in, and we're going to get 2 times 2 plus 7 times 1 equals 11. And we're going to get negative 4 times 2 plus 3 times 1 equals negative 5. And then we just do the arithmetic, and you all are doing real well with the arithmetic. You what to do to get 4 plus 7 equals 11, that checks. And we get negative 8 plus 3 equals -5. And that's it. So we're done. Now you might wonder what the advantage of this is. Well, one advantage is we don't have to keep writing out X's and Y's, but there's a lot more to it than that. Okay, this is a quicker process. And also, computers and calculators will produce matrices for you. So once you understand what's going on and are sure you understand and don't ever forget what's going on, you reduce these things using machinery, but you got to do 100 of them first. Okay. Okay, here's a system. I want you to do the same thing. Now, let's notice how this system evolved. The first thing we did, our first goal was to get a 1 here. Okay, once we have that, it's easy to get a 0 here. So this is what we aim at, a 1 here and a 0 here. And then next goal is to get a 1 here. And once we got the 0 here, it's going to be easy to get a 1 here. By whatever that number is, right? We get that, and then we want to get a 0 here. So it's like we want to get 1, 0, 1, 0. We look at the matrix. We want a 1 here, we want a 0 here, we want a 1 here, 1, 0 here. And when we have that, we see how it works out. We got the 0 here, then we've got a solution for 1. Yeah, 0 here and a 1 here. Then we get a 0 up here, we've already got a 1 here, that gives us a solution for us. Okay, see what you can do. I'll be looking over your shoulder. Give you a little help if you need it. Okay. You can write the steps into the matrix. Everybody got that? So what's our first goal? Our first goal is to get a 1 in this position. Got something wrong here. We'll figure it out. Yeah. Okay. I don't know where I got 17. I looked. My eye clock. I think I got that out of my peripheral vision. Thank you for correcting that. Okay. So again, our goal is to get a 1 here. How do we do that? We're gonna write this out. We're gonna say 1/3 of our previous row 1. Row 2, nothing we touched yet. Don't want to do too many things at once. Okay. 1/3 times row 1 gives us a 1. 1/3 of 3 is 1. 1/3 of 5 is 5/3. And 1/3 of -7 is -7/3. And I want to write it as a fraction times row 1 instead of divided by row, not divided row, for reasons that appear in linear algebra. How you get to determine the matrix, but keep track of these multipliers. It would confuse me to divide. Now, if you really want to do row 1 divided by 3, I'm not going to object to it, but it's better to write 1/3 times row 1. And there's a little confusion about dividing. So let's try to divide row 1 by 1/3. Okay, and that led a little bit of confusion, but the idea was correct. Okay, so now we've got our 1. What do we want next? Well, our goal. Have a 1 here, and a 0 here. And this is our goal. But we don't have it yet, so I'm gonna smudge it out. Okay. But we are gonna write down row 1. Because we're never gonna multiply row 1 by anything again. We've got 1 here. We don't want to mess that up. Okay, so how are we gonna get the 0 here? write a little lights in there. That's what we're gonna want, but we gotta do it by a row operation. So we're gonna have to add a multiple of row one to row two. Or subtract a multiple of row one from row two. Okay, now to get a zero here. We can't pull something from this problem, we can't pull anything out of there. All we can do is what we already know that we can do with equations. Multiply an equation, plot everything in the equation by some number, or divide by some number. We can add one equation to the next, or we can add multiple one equation to the next. Okay? So what we want to do is we want to add some multiple of this row to this row in order to get zero. What multiple of this row would we have to add to this row in order to get a zero here? Well, it comes down to what multiple of one would we add to 5 in order to get zero. Now, we've got a 1 here, and that makes it easy. Do -5 times 1 and add the 5, we get 0. You gotta do -5 times row 1 plus row 2. Okay. Yeah, we do -5 times row 1 added to row 2. How do we write that out off to the side? So I'm gonna write it out in a slightly different color. And we should, what we're actually doing with the matrices. -5 times row 1 is gonna be -5. -25 thirds and 35. Let's somebody done that. Maybe. What I really want to see, though, then I want to see row 2, which, yeah, we talked about row 2 here from the previous matrix. That's going to be 5. -3, 11. When we add these, we're going to have -5 and 5, which is going to give us 0. That's what we're after. But we've got to get everything else that goes along with it, and when we do, -3 is -9 thirds, that gives us -34 thirds. And 11 is 33 thirds, 33 thirds and 35 thirds is 68 thirds. Now that's written kind of small, kind of smudgy. But this is how we write it out. Off to the side. And we're gonna get, that's what we have here, is 0, -34 thirds, 68 thirds. Now I've got to go on to the next step, so I'm going to be very methodical about this. Okay, I'm going to rewrite the matrix up here just so better. Right. So we've got our 1 here, and we've got our 0 here. There could be anything in this with those numbers. What's the next thing we want to do? We want to get a 1 here. So how are we going to do that? Well, that's really pretty easy. We multiply the second row by -3 over 34. We multiply -3 over 34 by -34 over 3, we're going to get 1, huh? Okay, so we're still have our first row. That's gonna get in here, this is 0, 1. Now we've got our 1 here. Let's see what we get here. Well, -3 over 34 times 68 over 3. The 3 will divide out, and 68 divided by 34 is 2. So if we write it out there, we're gonna get 2 here. So now we know what y is. Y is equal to 2. We got. Hang on. That should be negative. I told you that, so you should it right back at me. Okay, that was good, thank you. All right. I think I'm losing some of my peripheral vision, it's natural, not a lot. Haven't noticed people sneaking up on me much, but I've gotta be aware of that. Okay, so anyhow, there we have. Now, what's the last thing we're gonna try to get? We're gonna try to get a 1 here. We want to get. I'm sorry, 0 here, right? So how are we gonna get a 0? Let's see what we've got. We've got 1, 0, and 1 here. Okay. Don't want those to change, but we do want to get a 0 here, and then whatever we get over there. And we're gonna have the -2. We've got everything except we need this 0. So the second row is not going to change, but the second row tells us that y equals -2. First row has to change. We've got to get rid of this 5/3, and that's going to, what we have to do is going to affect the -7/3. Because what we're going to do is we're going to take -5/3 of this and add to this. So we'll do -5/3. Of row 2 and add that to row 1. So go ahead and do that if you haven't already. Okay. So need to do -5/3 of row 2 and add to row 1. And that's going to give us a 0 here because -5/3 times 1 and 5/3 gives us 0. So let's write about -5/3 times row 2 would be 0. -5/3. 10/3. You didn't have a mistake on that. You got a -10/3. That's -2, right? Then we're going to do row 1, which is 1 5/3 -7/3. So what I saw is almost right, except that negative sign there. I just want to put a negative sign here, but somebody called me on it, so don't feel bad, but try to avoid that step. So when we add these, we get 1. When we add these, we get 0. When we add these, we get 3/3, which of course is the 1. We get 1. So now, see what we're gonna have. There it is. And our whole system is solved. So this is 1 y -2. Then we plug those numbers in. X is 1, we get 3. Y is -2, we get -10. 3 and -10 just come. X is 1, 5x is 5. -3x is 6. 5 and 6 is 11. Write that out, and you should. Which is for within seconds of being out of time. I'm not going to do it. Now I'm going to So we can do this, in 3 equations and 3 of them. Okay. Here is a straightforward translation. And everybody will understand this. What we're gonna get is first, we're gonna get 1, 0, 0. Now, the first row isn't gonna change. The first row already has a 1. We just locked up. Okay. How we're gonna get a 0 here and a 0 here? So we're gonna do row 2. Minus 3 times row 1. And while we're at it, we'll get a 0 here. We'll do row 3. Minus 2 times row 1. Now, we don't have time to do it, but here's our procedure. Okay, once we get a 1 here, we use it to wipe out all the numbers below it and make them into 0. Okay. I could tell you what's gonna happen next, but ideally, what we get is 1, 0, 0, and some number here. 0, 1, 0, and some number here. 0, 0, 1, and some number over here. So X is this, Y is this, Z is this. Once we get to 0 here, we're going to divide by whatever number we have here. And divide second row by this number to get the 1. And then we'll use that 1, wipe out the 2 above, and whatever number we have here below. Now, that's too much saying without doing it. We don't have time to do it. That's the process. Once we understand what the operations are, you can multiply a row or divide a row by any number, and we can add multiples of 2 rows. And with a little practice, because everybody's arithmetic looks good. Okay. Often arithmetic of fractions throws people off, but y'all are doing okay with that. So get over that and practice, and hopefully you're going to do well.